Hello students, so in this video we will be solving one very important question from the topic 3D geometry. The question says let alpha, beta, gamma be the coordinates of the foot of the perpendicular drawn from the point 5, 4, 2 on the line. This, okay. Then the length of the projection of this vector on the vector, okay. So it has two parts. There are two parts in this question. Firstly, we need to find the foot of the perpendicular. So in one of the previous videos, dear students, we identified how to find the image of a point, right? So if you have understood that, then this question would be very simple, right? So the first point is you'll try to find the foot of the perpendicular, right? So instead of alpha, beta, gamma, let me take the foot of the perpendicular in terms of lambda, okay? Now the equation, we have r bar is equals to a bar plus lambda into b bar. A bar is the point through which the line is passing, and what is that point here? The point is -1 comma 3 comma 1, and b bar is the direction of the line, so that is 2 comma 3 comma -1. Yes students, so a bar and b bar are vectors actually, okay. Anyways, the straight line would be x minus x1, that means x minus of -1 divided by a is equals to y minus b by y minus y1 by b is equals to z minus z1 divided by c. Let me equate this to lambda, right? So basically x will be equals to 2 lambda, x plus 1, right? So this should be 2 lambda minus 1, y should be 3 lambda plus 3, z should be minus lambda plus 1. So the foot of the perpendicular, I'm assuming it as 2 lambda minus 1, 3 lambda plus 3, 1 minus lambda. So this is any point on the line, dear students. This is the key point, right? This is we are assuming a point. And what is the direction of this line? Direction of this line is given by 2, 3 minus 1, right? Now let us say this is a and this is b. So let us find the direction ratios of AB, dear students. Direction ratios of AB vector will simply be x2 minus x1. So that will be 2 lambda minus 1 minus 5, which will be 2 lambda minus 6. By 2 minus y1, it should be 3 lambda plus 3 minus 4, which should be 3 lambda minus 1. And z2 minus z1, it should be 1 minus lambda minus 2. It should be minus lambda minus 1. And direction ratios of line will be 2 comma 3 comma minus 1. Now we know one very important thing, that AB vector dot L vector will be equals to 0 because these two lines are perpendicular. So what do I write? Now how do I take the dot product? It should be 2 lambda minus 6 into 2 plus 3 lambda minus 1 into 3 plus minus lambda minus 1 into minus 1. This should be equals to 0, right? So we get 2 lambda into 2 is 4 lambda. 4 lambda plus 9 lambda is 13 lambda. Plus 1 lambda is 14 lambda, okay. Minus 6 into 2 is minus 12. Minus 12 minus 3 is minus 15. Plus 1 is minus 15 plus 1 is minus 14. That means lambda is simply equals to 1, right? So if lambda is equals to 1, now the point B, the foot of the perpendicular will simply be 2 minus 1, which is 1, and 3 plus 3, which is 6, and then 1 minus 1, which is 0. That means alpha, beta, gamma is nothing but, so this is nothing but alpha, beta, gamma as per the question, dear students, right? Alpha, beta, gamma be the coordinates of the foot of the perpendicular, right? So then the length of the projection of this vector on the vector, okay. So what is that vector which is given? Let us say this is x bar and this is y bar. So what is x bar here, dear students? X bar will be I cap plus 6 j cap plus 0 into k cap, right? Because alpha I plus beta j plus gamma k, and y bar is 6i plus 2j plus 3k. Y bar is 6i plus 2j plus 3k, right? So what is he asking? He's asking us to find x dot y by magnitude of y, right? So projection of x on y will be this only, no? The length of projection will be x dot y by y. So what do we get? How do we take the dot product in the numerator? 1 into 6 is 6 plus 6 into 2 is 12 plus, if you want, you can write 0 into k cap plus 0 into 3 is anyways 0 divided by under root of we need to take the magnitude of this. So under root of 6 square is 36 plus 2 square is 4 plus 3 square is 9, dear students. So 12 plus 6 is 18 divided by 36 plus 4 is 40. 40 plus 9 is 49. Under root 49 is 7, dear students. So I think the answer should be 18 divided by 7, which is option number 3. Now let us go to the next question, dear students. Next question says, let a line L passing through the point P 1 comma 1 comma 1 be perpendicular to the lines, okay, this and this, okay. Let the line intersect the YZ plane at the point Q, fine. I think till here we can identify the line L and the point Q also. another line parallel to L and passing through the point intersects the YZ plane at point R, then the square of the area of the then the square of the area of the parallelogram PQRS. So this is another important thing. Many times we may miss this, and directly we may find the area of the parallelogram and then report a wrong answer, and it is a numeric integer type question, dear students, so let us be careful. Okay, so let us go step by step. Let us first find the equation of line L. It is passing through the point P. Acha. To find the equation of a line, we need point as well as direction. Acha, direction is given by the given line is perpendicular to this as well as this, right? So let us say A vector, which is direction of this line will be 4i cap plus j cap plus k cap, right? Direction of this particular line. And let us say B vector is the direction of this particular line, which is I cap plus j cap plus 0 into k cap is null vector I plus j ultimately. So now we need a vector which is perpendicular to A as well as B. So A cross B is the vector which is perpendicular to A as well as B, dear students. I hope you know that. So we will write 4 1 1 1 1 0. I hope you know how to find the cross product of A and B. So now if I expand the determinant along the first row, we get I cap into -1 minus j cap into -1 plus k cap into 4 minus 1, which is 3. So ultimately we get minus I cap plus j cap plus 3k cap. That means let us say this is C vector. Achha, the direction of C is direction of the line is along -1, 1, 3. So therefore equation of line let us say L will be x minus, now we have to take this point, x minus x1 divided by A is equals to y minus y1 divided by B is equals to z minus z1 divided by C. Okay, I hope you know how to find. Now this is the direction, right, dear students? So we will write this in the denominator and this part in the numerator. Now let us say this is equals to lambda. Right, now if I want to find the point Q, this line is intersecting the YZ plane, dear students. In the YZ plane, if you know, x coordinate will be 0, right? In the YZ plane, x coordinate should be 0. That means this part should be 0. That means x should be equals to 1, right? I hope you understood this. If x is 1, so then we get lambda as, if I equate this, so what do we get? X is 1, then we get okay, I think just we made a mistake. Should x be 1? Actually x should be 0, right? Because in YZ plane x coordinate is 0. So we'll do one thing, we'll equate these two. We'll say x minus 1 is equals to minus lambda, x is equals to 1 minus lambda. Now x is 0, right? Now x is 0 because on YZ plane x coordinate is 0, right? So lambda should be equals to 1. I think now we are going in the right direction. If lambda is 1, y minus 1, if I try to equate this, y minus 1 will be 1. That means y is equals to 2. And if I try to equate these two, then I'll get z minus 1 divided by 3 is equals to 1, z minus 1 is equals to 3, and z is equals to 4. So therefore point Q will have the coordinates as 0, 2, 4, right? Is that clear? Yes. So we identified this part. Now the next part is another line parallel to L. That means the direction of that line is along C only and passing through point S. Okay, it's passing through S. S is 1, 0, minus 1. So let us say that is let us say this line is L1, that line is L2. So equation of L2, line L2 will be x minus, x1 is 1 divided by, the direction is minus 1 is equals to y minus 0 divided by 1 is equals to z minus of minus 1 divided by 3. Let us say this is equals to mu. Now again this line intersects the YZ plane again at point R, right? Again that means x coordinate should be 0. So we'll do one thing, we'll equate these two. So x minus 1 is equals to minus mu, x is equals to 1 minus mu. Now put replace x with 0 because this point or this line intersects the YZ plane, right? To get point R we have to replace x with 0. So we get mu as 1. So if mu is 1, y minus 0 by 1 should be equals to 1, y should be equals to 1. And z plus 1 divided by 3 should be equals to 1, z plus 1 should be equals to 3, and z should ultimately be equals to 2. Therefore, what do we get now? We get the coordinates of point R as, point R will be 0, 1, 2, right? Now what is he asking, dear students? Then the square of the area of the parallelogram PQRS, right? Something like this. Now this is, let us say, PQRS, right? So what is the area, dear students? It will be mod PQ cross PS, right? Mod PQ cross PS. So I think we have the coordinates of point P, that is 1, 1, 1. Let us write it. And I think we found the coordinates of Q, that is 0, 2, 4. And coordinates of S are Acha, we don't know S, right? Okay, we know R, right? Anyways, we need the direction of PQ and PS. So PS vector is ultimately equals to QR vector, and that will be QR means R minus Q, right? So 0 minus 0 is 0, 1 minus 2 is minus J cap, 2 minus 4 is minus 2 K cap, dear students. And what is PQ vector? It should be OQ minus OP, OQ minus OP. So 0 minus 1 is minus I cap plus J cap plus 3K cap. Right now we have to just find PQ cross PS first. That will be I, J, K. In the first row I'll write, in the second row I'll write minus 1, 1, 3, and in the third row I'll write 0, minus 1 and minus 2, right? So if I expand this, I get I cap into minus 2 plus 3 is 1, minus J cap into 2 plus K cap into 1. So ultimately we get I cap minus 2J cap plus K cap, dear students. So this is PQ cross PS. Magnitude of PQ cross PS should be under root of 1 square plus minus 2 whole square plus 1 square. So ultimately we get 1 plus 4 is 5, 5 plus 1 is 6. So area is root 6. We want a square, that should be 6. So 6 should be the answer, right? That's it. Thank you for watching this video, dear students. Meet you with the next one.